So we're doing hyperbolas, the first video. So as you're flipping through the previous slides, you'll see these diagrams talking about what would be the differences between a horizontal hyperbola and a vertical one. So let's start with horizontal. So it's going to be looking like that. So our foci and our vertices are going to be on these ends of our asymptotes. These orange lines are our asymptotes. So let's just sketch in. Let's say that these are our vertices, which would mean our co-vertices are on the other sides of the asymptotes. Then our foci are going to tell us where does the hyperbola open. I'm going to mess up that word a lot during this video. Whoop. So our foci is telling us which direction is it being pulled outwards. So if we would do the vertical right now, we would have vertices on the vertical, or the up and down portions of our asymptotes, and then our foci is basically pulling it, stretching it away from the vertex against our asymptotes. Remember, asymptotes are lines that functions will never cross. We did that in a couple chapters ago. One thing that's missing from my diagram now is the co-vertices. Okay, so I've reminded us about the equations, where A is always going to be the distance between the center and our vertice. The B is going to be between the center and the co-vertice. And then to find the foci, we're going to use that C equation. So let us try some practice problems. So this is graphing hyperbolas given an equation. So let's do questions 1A. X squared over 4 minus y squared over 9 equals 1. So if it's equal 1, we don't have to do anything because we want them to be equal to 1. Since the x is listed first ahead of the subtraction sign, that means it's going to be a horizontal hyperbola. So the difference between these two equations is if x is listed first, then it's going to be horizontal. If y is listed first, it's going to be vertical. I like symmetry. Okay, so let's talk about our center. So this is written a little funky. You almost have to imagine it saying x minus 0 squared and y minus 0 squared. They didn't put that here, but we know that it has to follow this format. So our center is 0, 0. So to find our vertices and our co-vertices, we need A and B. Well, since this right here is A squared, our A value is 2, and this is B squared, so our B value would be 3. So you have to do a little bit of backwards thinking to find what regular A and regular B is. So since it's horizontal, this picture, from our center, the vertices are going out left and right. So the only thing that's changing is our x value. Our y value isn't adjusting. So when we write this out, we know the y value from the center is still going to be 0. We need to figure out what goes right here. So the distance between the center and the vertices is 2 units. That's our A value. So basically we're going to go to the right 2 and to the left 2 from our center. Oops, that needs to be negative. Oops. So negative 2, 0, and 2, 0. Then we'll do the same thing with co-vertices. Since co-vertices are now having a vertical change, we're going to keep from our center the x value and we're going to change the y value by a unit of 3. So it's going to go up 3 and down 3. It's supposed to be a 3. Alright, now let's do foci, or the focuses. I think foci is multiple. We need to find what our c value is. So the distance between the center and the foci is the value of c. So we're going to do c squared equals a squared plus b squared. So this is different than the ellipses. Now it actually is adding. It's basically the Pythagorean theorem. So c squared is equal to a squared, which we know in our equation. It's the first denominator, which is 4, plus b squared, which is 9. Add those together, we get 13. Square root of both sides, we get square root of 13. If we type that into our calculator, we should get about 3.61. So since our foci are following suit with the vertices, the y doesn't change, so it's still going to be 0, 0. The only thing that's changing is the x coordinate. So we're going to add 3.61, and we're going to take away 3.61, moving left and right from 0, 0. Our last step is to write the equation of the asymptotes. So it's going to be plus or minus. Our slope is going to be whatever b is over a. So b is 3, a is 2, so we have 3/2. And then we're going to follow suit. It's going to be x minus h. Well, it's minus 0, plus k, which is 0. So we can rewrite this as y equals plus or minus 3/2 x. And that's it. Okay, so the directions were to graph. So let's kind of do a quick help. When we're creating graphs, we should know what our lowest points and highest points are, both for x, y values and y values. So let's start talking about the domain. Domain is the x values. Before I even build my graph, let's figure out what's the lowest x value out of all these coordinates. The lowest x value is negative 3.61. So I'm going to say that my lowest value is negative 4. And then my highest one is positive 3.61, so I'll say positive 4. So that's for my x values on my graph. Then if I do y values, which is my range, I do lowest to highest. My lowest y value is negative 3. I'm just going to keep doing negative 4 and positive 4. This isn't exactly what it is, but this is going to help me create my graph. I already made some graphs on graph paper so I could save time in these videos. So for 1a, we're going to plot all that info. I like to start with my asymptotes. That just helps me out. So I know it has a center at 0, 0. My slope is 3 over 2. So I'm going to go up 1, 2, 3 over 2, down 3 over 2. So there's my first asymptote. I had a ruler. I don't know where I put it. Oh, there it is. So there's one asymptote, and then the other one is a negative of the same slope. So we're going to go down 3 over 2 this direction. All right. Asymptotes done. I'm just going to cover those up. Then let's plot our vertices. Our vertices are at 2, 0 and negative 2, 0. So there's a vertice, there's a vertice. I'm going to plot my foci as well. So it's going to be at 123.61. So it's like ish right there. That's kind of my foci. Negative 123.6 ish right there. And then my covertices are at 0, 3, 0, negative 3. And then I'm going to sketch in the hyperbola, which we want to start at our vertex. We want to get really close to those asymptotes. There's one side, and there's the other. Cool. So there is my graph. Kind of like a butterfly. Okie doke. So there's 1A. Your turn is 1B. I'm going to highlight in green your guys's. Or I was. I don't know what I did with my highlighter. Oh, there it is. This one's your guys's. So that one's for you. Let's do another one. So 1A and 1B are about hyperbolas that are centered at 0, 0. Let's try one that's not centered at 0, 0. So if we have y minus 3 squared over 36, all right. So the first step is to determine, is it horizontal or vertical? Since y is listed first, this is going to be vertical. Let's talk about our center, our HK, which is going to be changing the signs of both of these. So this is going to be 3, ooh, I just made a mistake. So like you would think it's going to be 3, -1, but we have to attach it with the y's and x's. So if it's vertical, the k is next to the y. So this is h comma k. That 3 is actually right here. And h is -1. So be careful. Since it's vertical, our k is listed first. When it was horizontal, we had our, well, this one doesn't really matter because it was 0, 0, but we'll see more of it later. Let's talk about our vertices and our co-vertices. So this regards to A and this is B. So if this is A squared, the A value is 6. If this is B squared, our B value is 3. Because remember, the denominators are both being squared in the equation. So the covertice in vertical, oh wait, I don't want to do covertice, I want to do regular vertice. The vertice is going to be going up and down from our center point. So if it's going up and down, then our x value isn't changing. So when we write our vertices from the center, the -1 is going to stay here. The thing that's adjusting is our y value. So if it's A, we're going to be adjusting it 6 units both directions. So let's do 3 plus 6, which is 9, and then 3 take away 6, which is -3. So I'm bouncing both directions off of the center. With the covertice, you look at our picture again, it is changing an x value from the center, but it's not changing in y. So we're going to keep our y value from the center. That 3 is not going to change, but we're going to adjust 3 units vertically. So we'll do up -1 plus 3, which would be 2. And then we'll go down -1 take away 3, which is -4. Okay, now we got to find our foci. Our foci is from C. So we've got this equation, c squared equals a squared plus b squared, which is 36 plus 9. c squared equals 45. C equals the square root of 45, which is kind of like the square root of 9 times 5, which is like 3 times the square root of 5, which if we type into a calculator is about 6.71-ish. So there's our C value. The foci for vertical, oops, if we're adjusting from the center, it is adding a C value up and a C value down, but the X didn't change. So we're going to keep the X value from our center, -1 comma something, -1 comma something, because that's not going to change. I'm going to highlight all of these because I think that's good to see. For the vertices and the foci, they all kept their X value. The only thing that was changing was the Y. When we did the covertices, we kept the 3 there. Hopefully that makes sense. Try to pause the video and look at that and see if you're following. The foci is changing the Y value by this many units. So if we add 6.7 units to 3, we get 9.71. If we take 6.71 away from 3, we get -3.71. I did that in my head, but if you didn't follow that, feel free to use a calculator, double check. I just did 3 minus this and got that. Now we need to talk about our asymptotes. Since it's vertical, we're going to be doing this A over B business. Y equals plus or minus A over B. So A is 6 over 3. X minus H, so it'd be minus -1, or just +1. Oh, wait. Yeah. Then we're going to add the 3. Yeah. Let's rewrite this, though. Y equals plus or minus 2, because 6 divided by 3 is 2. All right. Let's get going on graphing. Let's do the domain and range. The domain and the range of all these coordinates that we have to plot on our graph. The lowest X value looks to be -4, and the highest X value looks to be 2. I'm looking at that right here. And now the lowest Y value, I see a -3 point something, so let's go -4. And it's the highest Y value. The highest Y value I think is 9. So when I build my graph, I want to have an axis that goes at least down to -4 and up to 2 on the x-axis, and a y-axis that has at least a -4 and then the highest point of 9. So I've already made those. So let's do that. I'm going to start by graphing my asymptotes. Or no, my center is a good way to start. So let's go -1, 3. And now I'll do my asymptotes. It's slope of 2, so I'll go up 2 over 1, up 2 over 1. Are the asymptotes important? Yes. So it kind of gives you, the reader, a good visual of how deep these asymptotes curve. Sometimes they'll be really thin, sometimes they'll be really wide, so it's going to help us sketch. Okie doke. So asymptotes, done. Let's plot our vertices, which is at negative 1, 9, 3, 6, 9, and at negative 1, negative 3. So there's our vertices. I'm going to do my co-vertices, which is at 2, 3, and at negative 4, 3. Finally, the foci are at negative 1, 9.71, which is ish right ahead of 10, and negative 3.71 right off of 4, negative 4. I probably should have extended my asymptotes a little bit more, but that's okay. So I'll sketch in really close to my asymptotes. About that. And there. What I've seen some people do is that they look at their vertices and their co-vertices, and they kind of build this little box. I think it kind of mugs up the picture, so you don't have to do this, but if you were ever to like Google a video teaching you how to graph hyperboles, you might see this little box in there, but you don't have to do that. Okay, let's keep on going. So that was C. Here's going to be one for you, part D, 1D. That one's yours. Let's do another one together. That's supposed to be a negative 16. Okay, so for problems 1A through D, everything was already written to us in standard form. Now we're going to explore what happens when you have something not in standard form and how to put it in standard form. How do I know it's not in standard form? Well, it doesn't have denominators of squared. It's got numbers in front of letters, and it's not equal to 1. So that's 3 things that are telling me that it's not in standard form. So let us do some rearranging. Let's get all the like variables near each other. So I'm going to do x squared plus 10x. I'm going to leave this minus 9y over here. Like that. Now, the reason why I'm leaving space here is because I know I'm going to have to complete the square. Oh, I just realized I wrote this down wrong. Put parentheses squared. My bad. I was moving too fast. Okay, back to number 1e. We're going to have to put something in here that we can factor that. So how do we complete the square? We take half of the b value and square it. So half of 10 is 5. 5 squared is 25. But right now my equation is super imbalanced on this side of the equal sign. So I'll have to add 25 over here too. Whatever you do to one side, you got to do over here as well. All right. So this is going to become something squared minus 9y squared equals negative 16 plus 25 is 9. If we factor this, it's going to be x plus 5 squared. Okay. I'm getting closer to what it needs to be, but I still do not have a 1 over here. So what I'm going to do, I'm going to divide everything by 9. So now that I've divided by 9 everywhere, I finally have it equal to 1. These 9s cancel each other out, and I've got y squared. You could put y squared over 1 if you like the standard form looking that way. And then this just stays x plus 5 squared over 9. And we're in standard form. Okay, let's determine what's going on with this standard form. I'm going to put SF for standard form. So since x is listed first, it's going to be a horizontal. I'm going to use this space up here for my information. My center, this is kind of like y minus 0, so this is going to be negative 5 comma 0 for my center, my HK. My vertices and co-vertices are going to be dependent on my A and B. So if this is A squared, my A equals 3. If this is my B squared, my B would be 1. Okay. So it's horizontal. I'm going to show that picture again. So the vertices are going to be changing left and right, so it's adjusting our x value, not our y value. So in this one, let's squish them in. The y value is still 0. We're changing the x value by a unit of 3, both left and right. So if I take away 3, I'm at negative 8. If I add 3, I'm at negative 2. I'm changing the negative 5, both left and right. My co-vertices are moving up and down on the horizontal. So we are going to change the y value, but we're going to keep the negative 5. So we're going to change that 0 by 1. So it's going to be comma 1, comma negative 1. Now our foci, that needs our c value. So we need to do c squared equals a squared plus b squared, which is 9 plus 1. C squared equals 10, c equals the square root of 10. Type that into a calculator and we get about 3.16. The foci is going to move left and right, kind of like the vertices did. So it's going to keep the 0, but we're going to change this negative 5 that much in both directions. I didn't leave myself very much room. I'll zoom in and try to write very tiny, or a smaller pen. So if we take away 3.16, we're going to get negative 8.16. If we add it to this, if we do negative 5 plus this, you're going to get, I need a calculator, can't do that in my head. 5, or negative 5 plus 3.16, negative 1.84. If you can see that. Yeah. The last thing to do is our asymptotes. Since it is horizontal, we're going to have b over a. That's what our notes say, b over a. So it's going to be 1 over 3. So we're going to have plus or minus 1/3 x minus h, which is plus 5, plus k, which is 0. You don't need to write the plus 0 if you don't want to. Let's talk about domain and range. Our lowest x value versus our highest x value. I see a lowest x value at negative 8.16, so I'm just going to say negative 9. And oh, somebody's at my door. Oh no. I'm going to pause. All right, I'm back. That wasn't very long. Maybe I'll just edit that much out. Okay, so back to me is an asymptote of that. So let's graph that. Oh, I didn't do the domain range. Okay, now I'm back. So let's do the domain. The lowest point was -9. The highest point looks to be 1, I think. Yeah, 1. And no, the highest point x value is like -1. The range, lowest point looks to be -1. Highest point looks to be +1. Okay, so let us graph that. So we need a graph that has lowest point of -9, highest point of -1 for the x-axis, lowest point of -1, highest point of +1 for the y-axis. So there's that. I'm gonna fold this over. I'm going to start by plotting my center at -5, 0, 1, 2, 3, 4, 5. And plot my asymptote. It's going to go up 1 over 3, down 1 over 3. There's my first one. And then we'll do the other one, down 1 over 3. So this is an example where we've got like really short and skinny, I guess short and flat hyperbola. So our vertices are now at -8, 0, 1, 2, 3, 4, 5, 6, 7, 8, and -2, 0. There's my vertices. And then we've got our covertices at -5, 1, and -1. And then our foci are really close to the vertices. Good, great. So there's that. There's one. This is not 1D, this is 1E as an E for elephant. My bad. Okay, so we got something given to us not in standard form. We put it in standard form. We identified all the important information, then we graphed it. Okay, so 1F for you is (4y² minus 25x² equals 100. So this one you don't need to complete the square, but you'll notice that it has a value that isn't 1 right here. So your first step for 1F is going to be this blue step that we did in 1E. We want to get rid of that 100, so we're going to divide everything by 100. So that one's for you to do. Let's do one last one for me. I'll give you one more practice problem, and then this video is done. So this one's a little bit challenging. So it's got a lot more steps in it. We're going to have to complete the square 2 times. So it's not in standard form. It's not set equal to 1. We got to do a whole lot to this one. So step 1, let's rearrange everything so that like terms are with like terms. So if we have -4x² plus 40x plus y squared plus 12y equals 80. So now we're dealing with that. We have got to complete the square, and then this will have to complete the square. First rule about completing the square, it has to have a 1 in front. Since this one doesn't, I'm going to have to factor out a -4 out of everything there. So we'll have -4 times x squared plus 40x, oop, not 40x, we factored out a 4, so it has to be a 1. So it would be 10, because if we reintroduce this 4, -4 times x squared is -4x squared. -4, ooh, that should be a minus. Good golly, I am losing it. Because if we multiply -4 times -10, then we would get positive 40. I'm going to leave some crazy space to complete the square inside the parentheses there. And then we've got y squared plus 12y. I'm going to leave some space to complete the square. So let's do this. Half of -10 is -5. -5 squared is 25. So we're going to add 25, but it's imbalance, so we've got to subtract 25. Why am I putting it in here versus out on this side of the equal sign? Well, 25 minus 25 is 0, so that balances itself. Let me show you what would happen on this one. If I did this, which is half of 12 squared, which is 36, and then I wrote minus 36 here, to get that over, all I would have to do is add it. So why can't we do it for this one? Well, I can't just add 25 on both sides because this -25 belongs to that -4. So we can't move it over yet. Okay, let's start simplifying. -4, I'm going to change this to brackets because I'm going to start using more parentheses. For this much, it's going to be x minus 5 squared. I have to bring down this minus 25. What goes in here? That would be y plus 6 squared. And then we've got 86 plus 30, or sorry, 80 plus 36 is 116. All right, we're getting there. I really don't want this 25 on this anymore, so I would like to move it over here. But before I do that, I need to multiply by that -4. So you can imagine distributing this -4 to that 1 in front and to that 25. So we would get -4 x minus 5 squared. -4 times -25 is positive 100. Now I can move that 100 over. If I subtract 100 on both sides, 116 minus 100, I'm just going to get regular 16. I'm kind of stoked about that because it's a perfect square. So -4 times x minus 5 squared. This is going to get subtracted over. All right, we're looking good. I do not want 16. I want this to be a 1. So I'm going to divide by 16 everywhere. So if I do that, I'm going to get a negative x minus 5. Oops, that's extra parentheses I do not need. Squared over 4/16 reduces to 1/4. So I could put a 1 there, but I'm not going to. This doesn't reduce, so I'm going to leave it alone. Equals 1. All right. It looks like we're done, but it is not in the general form for hyperbolas because they need to be subtraction. This one's addition. So check this out. We're going to move this over here. Because addition we could invert as much as we want. This is kind of like us saying this plus negative that, but plus and negative is like subtraction. So we've got y plus 6 squared over 16. I'm just moving this to the front and moving this guy to its right. Now I'm in standard form. Woohoo! Okay, so we need to identify all that junk. First step, is it horizontal or vertical? Well, the y is listed first, so it's going to be vertical. Our center, remember it's h comma k, so the h value is with the x, which is this. So we're going to change it and make it 5. The k is with y, so we're going to make that -6 as our center. Now let's do vertices and co-vertices. This is our a value, so it's the front. If that's a squared, a equals 4. If this is b squared, our b is 2. It's vertical, so the vertices are going to have a vertical change from our center. If it's a vertical change, then the x value does not change. So we're going to, from this -6, we're going to add 4 and take away 4. If I add 4, I'm going to get -2. If I take away 4, I'm going to get -10. Covertices are going to go side to side, so the y value doesn't change, but the x does. We're going to take away 2 and get 3, and add 2 and get 7. Good deal. So we've got to find our foci now. Foci is found by c squared, so if we've got c squared equals a squared plus b squared, so it's 16 plus 4, c squared equals 20, c equals the square root of 20. If you type that into a calculator, you should get 4 something. 4.47-ish. So the foci, like the vertices, are not going to change the x values. But the y value is going to change. So if we add, or let's do take away because it's easier. -6 take away 4.47 is -10.47. I need a calculator for the other one. So now we're going to do -6 add 4.7, or 4.47 rather. 1.53. -1.53 is my answer. I've got a center, vertices, covertices, foci. What am I missing? I'm missing asymptotes. This is going to be y equals plus or minus. Since it's vertical, what does vertical tell us to do? Vertical tells us vertical a over b. So we're going to have 4 over 2. 4 over 2 is just 2 times x minus h, which is going to be -5, and we're going to add k. So if we do plus a -6, it's like -6. Okay. Let's do our domain and range. So that'll help us set up our graphs. Domain is our lowest x value. Lowest x value, 5, 5, 5, 3, 7, 5, 5. So it'd be 3. Am I crazy? No, that's right. And our highest x value, 5, 5, 5, 3, 7, 5, 5, so 7. Our range lowest value, -6, -10, -10.47, so let me say -11. And then our highest would be, let's see, I want to say it's this one, -1.53, so let me just say -1 for the time being. Okay, so you'd want to set up a graph that has a lowest x value of 3, highest x value of 7, a lowest y value of -11, a highest y value of 1, which I have right here for time saving, because I'm sure this video is super long. Okay, so let's plot our center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 están aquí. And our asymptotes have a slope of 2. Get my ruler. Okay. Next step, since it's vertical, it's going to be like that and that. So we're going to do our vertices at 5, -2, 5, -10. So if this is 5, -6, 7, 8, 9, 10, right there. Our covertices are at 3, -6. And it's going to be 2 out. So if this was 5, this is 7, -6. And I'm missing my foci, which is going to tell me how it opens. We've got 5, -10, so it's like ish right there. And this one is ish right here, close to it. It's like halfway in the middle. Final step, draw your asymptotes, get them really close to that, not your asymptotes, draw your hyperbolas and get them very close to the asymptotes. Good deal. And that one's done. Okay, one more problem for you, and then this video is done. 1H. 1H is, I'm going to block off some of this extra math. -36x² plus y² minus 6y equals -45. So a lot of negatives in there, so don't, when you're solving, when you're completing your square, don't lose a negative in there. And yeah, that's the last of this video. I'm just going to flash another picture of this. I would keep referring to these statements as I've been doing in this video, because it helps you figure out where the vertices and covertices are, where they should be, whether or not it's horizontal or vertical. And that's the end of this video. See you next time. Bye.